A student asked me a question about indexing. The question goes, can I edit my table? Can I create rows, delete rows, update rows while I am running a create index operation on a set of columns? So the question was a little bit more detailed. Like, can I update a field that I'm not indexing? Can I add a row that I'm not really touching any of the columns that I'm indexing? But the question, while it might sound simple, it made me think about the implementation details of how actually this works. So I thought I'll make a video about that. Let's discuss. So if you don't know, create index is a SQL standard which allows you to specify a collection of fields, so one field or more, and create another complete data structure. Often this is a B plus tree structure that allows you to short circuit your way to specific sets of rows. Very powerful data structure. But in order to create an index, you really need to read the table. So let's say I have an employee table and I want to create an index on the salary. It's a dumb index, but let's say I have it there, right? So that double column, I want to create an index on it. So the operation, if you would have to build it, I always tell my students that, try to build it yourself. Forget about the literature and the computer science and the professors and the books. Forget about all that. Build it yourself. You're a programmer. You know how to build this. Let's build it. Let's build an index. Well, to do that, I need to read all the salaries that exist in that column. I have to. That's how that's the beginning stage. And here lies the first problem. You're reading something that is constantly changing, right? Because the table is being, it's an OLTP system. It's an online transactional system. People changing, committing, rolling back, database crashing. You have a bunch of rows that you're not supposed to read to begin with, and you should not read it. All of that stuff you have to take into consideration. So most people said, all right, of course, the create index, I'm not going to go into the details of how the B tree looks like. Of course, when you read after you read all the salaries, you build your nice B trees. I have a whole videos about that, right? So you build that nice tree, and then to the right is the larger values, to the left is the smaller values, and finally the leaf, you put a key value pair where the key is your salary, the value is what really matters, which is the row pointer. Where is that full row? Because you really don't care about the actual value of salary. You want to get back to the row where that salary existed, right? So that's one part of it. But the problem here is really the reading part of it. And really the main reason why we can't allow create index concurrently with writes is because we're gonna miss edits, we're gonna miss some writes, we're gonna miss some rows. Why? Here's an example. So I'm creating an index, I'm reading, and then someone went and insert a row way in the beginning of the table. I missed it. So if I continue and I ignore that, I committed my index, it's in the catalog, so the planner will start using it. So if someone starts looking up for the value for that row, it won't be in my index because I missed it. And that is data corruption. That's mainly the reason why create index cannot allow concurrent writes, right? But there are ways around it. We're going to talk about that as well. Most database vendors says, all right, let's just block. You can't do anything. If I am about to create an index on a column, you can't add, you cannot update, you cannot delete anything. So create index acquires a special kind of lock that we call it conflict with updates, deletes, and inserts. and for that matter, even select for updates. But most databases that I know of, you cannot do any edits, but you can continue to read, right? So once you create an index, that operation blocks everything else, right? So that the create index takes finite amount of time, it builds your structure, and then it commits and done, and then it releases that special lock so that other operations can continue. That's why creating an index can be expensive, right? So as a result, it blocks other operations, right? And people don't like that. Like imagine you're doing an insert and all of a sudden your transaction is blocked. It's like, what's going on? By block, I mean it's just waiting there, right? So in production system, people often don't use create index like online like that, right? But most of the time, this won't work. So we need another way to create an index that is concurrent with edits. And that's why Postgres have to create index concurrently, you know, which allows you to edit. It allows you to insert and update and delete. So that's where that question came to my mind. All right, I know that while you do create an index, you cannot edit the table. When I say edit, I mean insert, update, delete. It's just that's a GIS thingy. Like we say edit, and that's what I mean by edit, right? It might not be a database thingy, but that's the terminology that is. But create index concurrently allows it to do that, allows you to edit the table. The question is how? Well, here's one method that I found out. If I want to implement something like that, I don't know the implementation of how create index can run concurrently with other edits. That doesn't make any sense if you think about it. It's like, because that's really dangerous, right? So they must have solved it in a way such that it does not cause a problem. But here's the thing, if you read the documentation of create index concurrently, it's almost 2 times slower than the actual create index. Why? Well, let's talk about that. So if I were to implement this, at the moment of create index, I would take note of the last committed wall entry, which is the write ahead log. That's how I would do it. This is where the last time is actually something has changed in the database. I'm reading the snapshot, almost I'm reading a snapshot at this particular moment, right? And then I'm gonna read everything in that table, right? And I'm gonna build my index normally. At the end, I'm gonna evaluate. Of course, meanwhile, people have edited my table. People inserted, deleted, right? So now I need to revise. I'm gonna get a brand new, I think it's called LSN, log sequence number, right? So I'm gonna get that log sequence number, the new one, because it has changed. And then based on the diffs of what has changed between my beginning LSN and the current LSN, I will read only those changes and will apply them again. So this changes should be way smaller than the entire table, of course, right? So I'm gonna start applying the index again. It's like as if someone is just changing this new index on the fly, right? All right, and I'm gonna do this. Before I do that, I'm actually gonna take note of the last LSN, right? And then do that operation. Then, after I apply these divs, I'm gonna check again. Did someone actually make changes between my last and the new one, right? And of course, it might actually be that the fact that more people actually made these changes. So we'll do this again and again and again. So there might be a chance that with this implementation, create index concurrently will never finish, right? But it will catch up eventually. That's my guess, at least. Okay? But the thing is, we really cannot make the index available for use until we completely sure that we are absolutely done that moment where we're absolutely at the end of the index. The last log segment is the same as the last log segment from from when I actually started. Then I know that, oh, nobody changed. Quick, let's commit. And when we commit, we actually commit the catalog changes, like the metadata. And then all of a sudden, poof, this index became available online. Right? And of course, that's how I think about it. And that's how you implement it. And then it kind of explain why create index concurrently is slow. Now, I like to do this kind of thing to see how I would write something, because when I look at the thing, most of the time my implementation is atrocious, right? And I went way wrong. But it will be interesting to look at this and actually compare it with the actual implementation, because if Postgres is open source, we can actually look at the code and see how they implemented it. But yeah, guys, that's how I want to talk about here. Create index concurrently, right? Almost always production use create index concurrently to actually add an index, or while on actively, right? While the database is being actively edited. All right, guys, that's all from me today. See you in the next one.